Hello, everyone. My name is Jithin. I'm an engineering manager here at Oath, and I manage the Screwdriver team. So Screwdriver is a CICD tool, which is a hosted, centralized tool catering to the build, test, and deploy use cases for all the Oath developers. Right. A quick overview on stats. So we have over 30K projects or pipelines, which defines the build for your individual Git repositories. And we run over 30,000 daily builds across various teams. And we support almost 10 plus programming languages. And the way we standardize the support is through something like templates. I'll quickly demo what templates are. And we have over 500 hosts running builds and the application of Screwdriver itself across multiple clusters. And a brief history of Screwdriver. Screwdriver started around 2011 as an internal tool, right? And it went through multiple iterations, and all the initial versions, it was based on catering to our internal developers and built using internal proprietary technologies. So then we started looking at what's next for Screwdriver. And that's when we totally revamped or re-architected how it should look like and contributing back to the open source technologies. So with the latest iteration of Screwdriver, we are running on Kubernetes. Everything is containerized, including our application and where the builds of our users run. Overall, feature-wise, we still cater to 3 basic CI/CD use cases. Building your application, no matter what the programming language it is, Go, Node.js, publishing it to maybe Artifactory, Docker registry, or whatever internal tools you use to store your software, then deploying it to whether it's on-prem data centers or to our public cloud like AWS or G Cloud. Then one of the philosophies of Screwdriver is your pipeline as a code. Right, so all the configurations for how your pipeline or your workflow looks like, how you build it, how you test it, and how you deploy it, everything you configure that in a single configuration file called YAML file called screwdriver.yaml. So this is a small snippet of a very simple screwdriver.yaml file, which defines 2 simple jobs. Like you have a main job, which it's an example for Node.js, and you have a publish job. Right, and in order to use Screwdriver, all you need is a Docker container. Like you can you can define which Docker container should run your build. You can use something directly from Docker Hub, like the one in the example which uses Node version 6, or you can build it your own. You can publish it to your internal or external Docker Hub and use that, bundle all your build tools in it, and use that for your build. Right, and we support multiple build executors. Like we don't define that you have to use Kubernetes or you have to use Docker for running your builds. You can bring in custom executors. You can run your builds in Jenkins. You can run your builds in Kubernetes. You can run it on Docker directly, or you can run it on a virtual machine. And that's the way we did on internal inside Earth. And a quick overview on few of the basic tenets, like pipeline as a code. Like as I shown before, you can define everything in a single YAML configuration file. Then you have containerized application components. So all the Screwdriver components, like its UI, its API, its data store, everything we build from our open source, and we publish that to public Docker registry. And the way we deploy the application internally at Oath is by pulling them from the public Docker Hub. So we don't have anything customized specifically for internal and then push that to open source. So we develop the application directly against our open source, and we pull that internally. And containerized builds. So even the builds, they run on an on-prem Kubernetes cluster. So, and if you want even stricter build isolation, we use a VM executor based on hypercontainer technology. So this is for providing strict build isolation for security reasons. Like even if you run directly on a Docker, there are cases like you can still break out of Docker and get access to the base host. So if you want a stricter build isolation for security purposes, we run that inside VM. And community-based support. So internally, there are a lot of subject matter experts on various programming languages. Like we do the CI/CD best, but if you want deeper expertise on your build is failing for Go and why is it failing, like we leverage the overall developer network within Oath and the solutions and the support we provided based on a community effort. And so templates and commands, there are two functionalities which we provide in Screwdriver. Templates is something which abstracts a job, and commands is something which abstracts out a single step in a job. So if you are a subject matter expert on, say, Node.js or Go, then you can define like, okay, this is a template for all Node.js builds. Let me show you a quick example. So this is how Screwdriver UI looks like for templates. And here we have two templates for building a Node.js lib and a Node.js app. So what templates defines is it defines a Docker container, and it defines a bunch of reusable steps. So whoever is using this template will get to use the same Docker image and same steps. So this way you can build standardization around how your developers should be building application. Like what are the specific tool set they should be using, and what are the secure ways in which they can publish that to whatever Artifactory or Docker registry they are pushing this to. Yeah, so now I will be demoing a bunch of the use cases we support. So I'll quickly go through this advanced pipeline workflow. So this is example pipeline we have created in our open source. So this is our public GitHub repository available at screwdriver.cd. So all the software development we do, this goes against our public Screwdriver, and we pull that internally. And we have an open source instance of Screwdriver available at cd.screwdriver.cd. And this is available for everyone to browse. It's not restricted to Oath. And there is also guest access. We do support a guest access based login, and thanks to our own engine. So if you want to browse around all the pipelines available in public Screwdriver, you can just come to screwdriver.cd.screwdriver.cd, just log in as a guest and explore around how the configurations are and how the workflows look like. So let's see. And this is a workflow example where you can run multiple parallel builds using fan out and merge them together at one point. So if you look at this, what the graph is telling you is there was a code commit which happened on your source code on a CM repository, which started the job A. Then once the job A started, it started two jobs, B and C. Then it waited for, once both B and C are completed, now I can't run a job because I don't have the necessary permissions because I am a guest. But I can switch to my GitHub account and try the same thing. Just hold, yeah. Yeah. So in Screwdriver, everything is an event, right? That's what you see on the bottom tab of the UI. Yeah, and event represents a specific SCM commit which happened on your Git repository. Like what it's telling me is that I started a job through the UI, and right now it's waiting to run the job A. Oh, went pretty fast. So now job D is running because both B and C got completed. And if you look at the Screwdriver configuration which makes this happen. So as I mentioned before, everything happens through your YAML file. So this is just the simple configuration which makes the previous workflow happen. So you pretty much say, establish requirements or dependencies between your jobs, and that's what builds this workflow graph in the Screwdriver UI. Another use case is remote trigger. Like, how do you define dependencies between various pipelines? So you have one pipeline, maybe building your application and pushing it to your Artifactory, and you have another pipeline which deals with the deployment of it to your internal data centers, right? So within Screwdriver, you can define these complex dependencies between your pipeline, and this is the syntax which makes that happen. You pretty much say, okay, you give each pipeline has an ID, and you say that, okay, this is the ID which can trigger this specific job. So once the job C in that external pipeline finishes, then then that will trigger this specific job B, which is in your current pipeline. So this way you can chain together multiple different workflows. Then this is an example for you can define dependencies within your own jobs within the same pipeline. Say, you can say that when my job A is running, I don't want my job B to run, right? So even though both of them are defined to be, both of them are defined to run at the same time. So this way, if, say, suppose you are doing a deployment to one of your data centers and it's running some test, and say the test job already started, then you don't want another deployment to go through at the same time, because then that might affect the current test suite which is being running and will lead to unintended consequences. So this is how the UI looks like when this block byte takes in effect. So these two jobs, BB job 2, so it has a dependency that it shouldn't run when job 2 is running. So it kind of pauses and it waits for the job 2 to finish before it proceeds. So this is another advanced workflow where you can define different projects or different jobs based on different branches. So suppose your master has all the latest application running and you're working on a feature, say suppose feature 1, and it's not yet ready for prime time. So you keep writing your code and checking everything to your feature branches. So you can define workflows within your main pipeline itself, like run this job if a commit happens to any of my branches. So if we look at this specific event, a check-in happened. What it's telling me is that a check-in happened on my staging branch. So let's quickly look at the check-in which triggered this workflow. So this happened on a branch called staging, and Screwdriver picks up the correct picks up the check-in and runs the job which are configured for that specific branch. So that workflow config which makes that happen is, so you pretty much specify that, okay, run this job if a commit happens on in this specific branch. And this is an example where if you follow monorepo, like you have various source code under your same Git repository, right? You have your library on one path, your Node.js or Java on another path. So you can define workflows with Screwdriver that run this workflow only if a check-in happens on this specific directory within your source code. So let's look at how the source code is organized. So I have a directory called alpha and another directory called beta. So what Screwdriver is doing is, if you have any code changes in the alpha directory, then the workflow for alpha will kick in. So let me look at the specific source code change. So this is a check-in which happened on the path alpha /, right? And Screwdriver has, if you look at the Screwdriver config, it has this directory called source paths. So basically with the source paths, you can control on what code check-in will trigger parts of your pipeline. And this way you can configure your one single pipeline to build all the different components in a monorepo. So one of the recent features we did is supporting a build cache. Right. So one of the most commonly asked use cases is, okay, I produce some artifacts during a build. Right. My one job A produce an artifact. How do I make it available in job B without having to push it to some external artifact tree? And another use case is, say, suppose you are building a Java project or a Node project, which where all your dependencies are stored under Node modules or the M2 folder. During your each build, you are downloading all these dependencies again and again, triggering lots of network calls. So, and these dependencies, they don't change quite often. So you have a good use case here that you can cache all these dependencies and reuse them if they haven't changed it. So with the build cache feature, you can say that, okay, cache parts of my directories, like cache my M2 directory, cache my non-modules directory. And if it is cached, and if your build tools recognize that cached information, then you are saving potentially hundreds of network calls, which can speed up your build time significantly. So in Screwdriver, you can define caches at multiple scopes. You can say cache something based on at an event level. What that means is your cache information will be available on one specific event, but on subsequent events, they are gone. And the second case is cache it across jobs. Suppose one of your jobs is building Node.js application, right? And you can say, okay, cache the entire Node modules directory. So all the subsequent jobs will have access to the same Node modules. Or you can even say cache it across the pipeline. So you have multiple jobs, say dealing with Java and same dependencies throughout your workflow. So you can say job A cache. Let's look at a config. So you invoke the cache using the cache config, right? And there are three scopes here. One is for event, non-modules. Then across the pipeline, your Gradle. And for a job, just test path. So if I run the build and and if I go to the build details, and this is where the magic happens. So we look at your configuration and we look at whether the cache data is available. And if so, the build pretty much download everything's your build container and make it available in your build environment. And the subsequent steps, your build steps can make use of that. So that's pretty much I wanted to talk about the features on a higher level. Oh, and yeah, SonarQube. So in Screwdriver, everything are temporary build containers. So once your build is done, all the containers are thrown away. So in order to persist your test results, we push all the results of your build to a SonarQube instance. But that means that once the build is done, you need to have configuration in your job to say, okay, these are the settings I need to enable that for the Java project or Node.js projects. So once you provide the SonarQube configuration file, then Screwdriver pushes this to a self-hosted SonarQube instance where all your test results are available. So if we see a quick example, so this is a Node.js, it's a Java application. And once your test results are available in SonarQube, we display the information on the detail page. Like you say, okay, it has 89.9% coverage. And once you click it, it will take you to the SonarQube instance where you can have more detailed analysis of your build, like what's the coverage and how many unit tests it ran. And so some of the upcoming things we are working on is providing user-provided custom build clusters. So today, Screwdriver is a hosted infrastructure. That means that we provide your the infrastructure where the build runs. So we provide on-prem data centers, Kubernetes clusters where a user build runs. But sometimes you have specialized use cases, like your build needs specialized hardware or say Windows or Mac. And if as a user, they want to bring their own build cluster, then we want to provide an infrastructure where, okay, send all the builds to that specific build cluster. Then one of the other items you want to tackle is providing more build metrics, like how much time a build ran, how much time individual steps of a build ran, and provide metrics around it. So today, the main metric you have is on the UI itself, you saw what's the start time and what's the duration. But we want to provide more metrics such that you can see the overall trends on how your build is behaving. Yeah, and these are some quick links on all the docs and everything they're hosted on open source. So screwdriver.cd is the landing hub from which you can find all the information. So docs.screwdriver.cd, that's where you can find pretty much all the documentation. And if you are using Screwdriver open source and if you need support, this page has all the information on how to reach out to the team. We have a public Slack channel where the team hangs out and you can come ask questions. And if you are interested in contributing to Screwdriver, this is where we have provided all the guidelines on where do you find various components of Screwdriver and how do you create a pull request and in what format and code quality we expect a pull request. And that's pretty much. Any questions? So most of the UI, API, and store, they're written on Node.js. And the core components which runs your build, like we have a launcher, we have a log service, they are written in Go. These are the two main. Yeah. Yes. So the question was, is Screwdriver itself running in Kubernetes? The answer is yes. So all the Screwdriver components, the UI, the API, the data store, they are available as Docker containers, right? And these Docker containers, they are, in fact, Screwdriver is built using Screwdriver itself. The open source instance cd.screwdriver. Yeah, so this is the pipeline for Screwdriver UI. And it builds your code, it publishes to Docker registry. That's what's happening here. It publishes to Docker. And we deploy that to a beta environment that is running in Kubernetes. So if that goes good, we run some basic functional tests. And if that all goes good, it eventually gets pushed to a production environment, which is a Kubernetes instance. In fact, that's the same instance where this is currently running on. Yeah, so the question was whether for each build a new container will be instantiated. Answer is yes. So each build runs on ephemeral containers. So once the build is over, it's destroyed. So that's one of the reasons why we needed integrations like SonarQube, where you want to have some persistence of your build results. But what that brings is each time you have a clean environment where your build is your code is built. So there are less inferences based on some code lying around or any dependencies which you assumed you have on your dev environment kind of place. So the question is, other than GitHub, what are the other login solutions? So Screwdriver has support for login for GitHub, GitLab, Bitbucket. So mainly any SCM provider which supports OAuth, we should be able to integrate, because but the main focus was on GitHub because that's what we use internally on an enterprise level. Basically any SCM provider, if you have OAuth, we should be able to support it. And it's done in a pluggable way that you can create a new project. Say if you have some new SCM where you need support, you can just extend our base classes and create something new. Yeah. So the question was, why did we have to create something like Screwdriver and not use something like Jenkins? So so this is the fourth iteration of Screwdriver, and all the initial 3 versions they use Jenkins as a backend, like as an executor. So one of the reasons for building something like Screwdriver in the first place was creating a workflow, and which is very easy for you to define as a simple YAML file. And you get a nice UI where you can quickly visualize, okay, this is my pipeline, this is the job. And looking at the pipeline, you can say where my code is at that moment, at which job is running. And if you want to have like, hey, I want to retry my build at one specific point in time, you can do that. And after version 3, that's when the scale at which we do things grew exponentially. And that is when we started seeing limitations in terms of performance of Jenkins-based instance. So we are running almost 30,000 builds a day, and slaves go offline all the time, and we have to cater to the security constraints which you need at enterprise level. Jenkins simply was not scaling for us at that level. So then that's when we totally relooked at how we can build it based on a modern infrastructure. And that's when we re-architected based on a containerized way using Kubernetes, Docker,